Yeah, and let's create a file, just like intro functions.py. And let's create our first function. So, and there is a specific syntax to do that. So I'll just show you how it looks like. So basically this is an example of the function. To specify a function, we need like to use a keyword def. Then there is a function name goes after that. Our first function gonna be greeting. So this is the name of the function. And then we open like a brackets, and inside of the brackets we put all arguments. So there could be like arbitrary number of arguments. In this case, we have just like one argument. And then we put column symbol, and there is the body of the function. So it's like similar in the way that we saw for the conditional statements, for the loops, that if you want like to specify that some part of the code belong to kind of, for example, to the conditional statement or to the loop, or in this case to the function, we need like to use indentation here, and then we can like put arbitrary code inside of the function. And here you can see that we created a variable inside of the function which is called result, and result is like simply the concatenation of some strings. And then in the end we use a specific word return. This is a statement, and this is gonna be result of our function. So let's just like write this function and try to run it, call it. So, and basically, yeah, the idea is that in the beginning we need to declare our function. And let's just like repeat the code that we saw there. And I'll slightly change it since we saw the f strings in Python, so I can use f string instead of the plus operator for concatenation of the strings. And this is our function. So, and basically right now we just like specified it, and if we execute our program, let's just like run it, we will not see any output because this is just like a declaration. And now after that we can call this function over and over again in our program. So how to do it? We just need like to use the function name. In our case it's a greeting, and then inside of the we should like also put the brackets here, and in this way we are like saying that we want like to call our function. And let's put some name here, for example John, and let's print the result. So because this call gonna return us the result, and we want like to print this result right away by using the standard print function. So, and you can see that instead of greeting of John, we got the string which is a hello John. And this is the main concept of functions. And I have a question for you. So in general, why we are like kind of doing programming in your mind? So why we like write programs? What we wanna achieve in general?
You mean what is the purpose of the programming?
Yeah. So why we are like doing that in general in your mind? So it can be like any. What do you think?
I think maybe to make our work much easier, maybe to do something quicker as we can, because programming can count faster than humans, for example, to do some mathematical operations faster than we can by ourselves.
Agree, totally agree. So yeah, the idea, I'm like also sharing this point of view that in my mind it's also like we are trying to simplify our like some routine tasks, and to do that we are like programming. So for example, there is like indeed some complex numerical operations that we still probably can achieve, I mean like resolve them manually, but it's gonna take a while, and programming is like a nice way. And when we like write a program, so let's think in the same way that we want to like simplify our like tasks in general along our path. And to do that we need like somehow to write efficient code in terms of that we will kind of not spend a lot of time on that. And before, for example, we already saw that sometimes we can like use some specific concepts in programming which gonna help us to simplify our code. And one of the examples that we saw, it was like variables, because we don't need like to, for example, specify the same value over and over again in like through the lines of code that we have. We can just like create one variable, assign the value that we want, and then like refer to it, then like replace, rechange it. And in this case, so for example, we have like a function which we now can call over and over again, and it like give us a new opportunity, not like to specify. For example, in this case, it's like a simple function. There are like just 2 lines of code which specify the body of the function. But sometimes it's like could be some more complicated function. For example, if you want like to resolve some numerical equation, there could be like plenty number of lines inside of it. But now, what is cool of it? We can like provide some input data to it, and then get the result after that. So, for example, now we can like change the input of our function. I don't know. Let's put like Robert and run it again, and this is give us like a nice way to reuse the code that we already wrote. And so guys, for example, the another solution for that would be like I could like, for example, over and over again print like something like that. So I could like create a new variable, assign something here, and then like use a print f, something like that. So I mean, like, I could, for example, copy and paste it like multiple times in my code. And what do you think, guys? What are like the drawbacks of that? What could like, be a problem with this type of solution?
Maybe it will have an impact on the time of algorithm. Maybe it will take a lot of time if we will write a lot of time like result print, so instead of using function.
Yeah, so I'm not sure about the time taking from the computer side of it. I mean, like, so for computer, maybe it's, I mean, like, it depends on the situation. For some cases, I believe it's gonna be relatively the same. But from point of view of the human working hours, right, it's gonna take like much more time because we need like to copy and paste over and over again. That's true. Maybe some other like ideas, guys, if you have. Yeah, don't be shy. Like, just try to, guys. If you have any idea, just like drop it.
Or maybe if we have a lot of text of program, something could be changed occasionally, and there will be error.
Yeah, that's a nice one. So yeah, this is a I like it. So the point that, for example, if there is like some mistake, right, inside of it, we will like copy and paste this mistake over and over again, which is like not very nice because we will have the same error through the code. And sometimes, so the problem is that it's like in the end. So for example, you can like understand, yeah, there was a mistake somewhere, and then you need like to fix it in all places where you reuse this part of the code. And in general, yeah, so, and in this case, we now can think about it in terms of the function. And then for function, we have like a declaration, this like where we specify the function. And if we made a mistake, we made it just inside of the body of the function. And then for us, it's much easier to debug it, to find the problem inside of the function, resolve it, and like once you resolve it inside of the body of the function, you can like run the program one more time, and it's like fixed everywhere. So it's much more easier to handle some issues in your program if you got it in the function. Also, I had like some visualization here. I don't know, maybe it can help us to understand what is the idea. So basically, we can like also think about function in the way that usually we have like, for example, the function itself, and usually we suppose that the function takes some input. So let's say that we are like working on the matching application, like we want like to build the application to match pairs of the people by their interests, for example. And then we can like provide some information about the person as an input, and then we want like to find the match inside of our like database, for example, based on the, I don't know, that they like, let's say that these people, they share similar interest in something, and then function gonna like give us the output. And this is the main idea, that we can think about function in the way that we have like some input, then there is a function that performs something inside of itself and give us a result. Also, sometimes we could like you can like omit some part of it. So for example, you can specify the function which don't need like to get any input data. It can like just provide the output. Also, it could be opposite, but this one is like usually harder to think. So basically, if there is like no output, then what was the reason of the function? Somehow there is a function which are like performing something in place. For example, if you had list and you wanted like to change it, then you can like change it, and you can like just not return anything from the function, but still it like changed something in the object that you had before. So in my mind, I still think about it as there was some output, even if it's not like something explicit. So yeah, this is functions. And now I want like to show you one important thing in my mind, which is like sometimes not like, okay, usually it's like better to specify it in your programs, but in case if it's like some draft, usually people like skipping this step, which is called like docstring. And docstring, it's like some like comment that you can put inside of the function, and then people are able to get the information about your function. So let's just take a look on some built-in examples. We know that print, it's like a built-in function. So basically someone like specified this function for us, and now we can utilize it. So that means that somewhere there is also like implementation of the function. We don't see it right away in the program, but we have the access to this function and we can call it. And now, for example, if I open the brackets here, you can see that I got some information about the function. So this is basically the information about arguments that function takes. And it's like showing that, for example, the result is none. We can provide like some values here. Then we can specify the separator. You can see so that the separator, the type of the separator is string, or it could be none. And by default, the value for separator is a white space. There is also like argument end, and so you saw that at some moment we will like specifying these arguments in our programs. So, and basically this is an example of the arguments, and we got this information. But the interesting part that there is a kind of documentation of the function. So prints the value to a stream or to system standard output by default. There is like optional keyword. So that means that there is some documentation, right? And we also like as cool programmers can specify our own documentation in our programs. And to do that, so we need like to specify a multiple line comment. So let's just open our let's just go to the function that we specified. Oops, sorry. Yeah, I just copied it from the website. And basically to specify a docstring, we need to put a multiple line string, or just like string, right after the name of our function. So here, after like def name of the function, we need like to put it right in the beginning of the body of the function. And here we just like provided that this function creates a greeting message for the given name. So we have a name. We also like specified what kind of parameters, or like you can also call it like arguments function takes. In our case, it's like a name. You can specify here that it's like string, but there is no like any checking. I mean, like, we just like put it in a documentation, but in general, person can, someone can provide not string, but something else. And sometimes it could lead us for some problems, but in this case, we will kind of just skip it for now. And then also we specify what is the so what function returns in the end. And so we're saying that it's a string concatenating the personalized greeting. And now, I don't know, let's just try to check it if the Visual Studio Code by default can get the information from that. And you can see so that it really kind of fetch the information. It shows us now that the name string is string representing the name. Yeah, this function creates a greeting message for the given name, returns out string, a string containing the personalized greeting. So it's like somehow like formatted a bit the what's called the doc string that we specified. Yeah, and basically this is a doc string. Also, another way to get the information about the doc string, in case if you, for example, are working not in the Visual Studio Code but in some other environment, you can simply call the help function. So help function is also the default built-in function, and we need like to provide the name of the object. In our case, the name of the object, it's a greeting. So greeting, it's also an object which refer to function. And let's just run it. And you can see so that I got the help information here. And probably, if I am not mistaken, maybe I even don't need to use print function here. But let's just take a look on the help that we got. So help on function greeting, and there is a location where this function is like, it's like in the module called main, and this is a simply the documentation for our function. So this is a greeting name, and there is a documentation. So basically now you can like write your function, specify them, like put the documentation. And yeah, so guys, one more time question for you. So why you think we need like to specify documentations for our functions?
Maybe not to forget why we created them.
Yeah, for example. Also maybe some ideas. So I don't know, some ideas.
When we have a lot of functions, not to...
Yeah, like not to forget what they are like doing, right? Yeah. So this is a correct. Yeah. So I mean, like this is one of the ways how we can think about it. That for example, if you specified a function, and for example, if you specify that with some strange name, you put like some, I don't know, you call it like my custom function without specifying anything, then it's hard to understand. If you go like back to the code after like a while, you probably will not be able right away to understand what function do or does. And yeah, so this is one of the points that we can like argue that it's needed to be there to, for example, simplify the process of like recalling what was the function. But maybe some other ideas.
Maybe if you want to share with someone with our function, with our colleagues or coworkers, etc. Because sometimes we work with the project and there are a lot of people there, so we need to share our code, and maybe for other to understand what for.
Yeah, that's correct. This is also like another point that very important. That yeah, so I believe at some moment, I mean, like if you are like kind of going to choose the path of be like a programmer and to program some things, I believe, and at some moment, for example, you will face with the situation. Either you're like providing your code to someone, and then if you specify the documentation, then it's much easier to another person to understand what is the purpose of the function and what it's supposed to do. Yeah, but also you can think about it as a, so I mean, like, you know, like there is some statement, I don't know, the one guy, like the one smart guy said that you should like act in the way that you are like supposing that everyone else gonna act too. So you can like kind of as yourself be as an example to everyone. And sometimes, for example, you can face with this with the following situation, and you're gonna like then appreciate the documentation of the functions. Sometimes you can, for example, work on some tasks which are not so popular. It's not very popular, and you need like to find like, for example, some already implemented functionality in the internet, and then use these functions in your code. And usually people lazy to do that. I mean, like to write the documentation for their like functions, for their like other like things. We'll see that there are like also documentation not just for function but also for classes. And then, for example, I am like a person who trying to utilize their like solution. I'm like, I found the internet web page. I'm like, okay, it sounds like that's something I can use, but then you see that there is like no any documentation, nothing, and you're like, okay, I cannot use it in any way. So sorry, man, or sorry, person. I'm gonna like skip and try to find something else. And this is the idea that usually it's like very useful when you're like working with others' code, or you are like you want like to share it with someone. And just as an example, we can like also try to check something. For example, there is a like a package which is called like scikit image Python, and this is a like a module. And usually if it's like a very well developed module, people like following this recommendation. So there is just in general documentation, right? But also we can, I don't know, try to find some functions here. For example, let's try to find the resize. Yeah, and this is a function, and then you can go like to the code, to the source, and let's hope that there is gonna be documentation. So yeah, it's like loading. Yeah, and so you can see we opened the implementation of the function. So someone like wrote this function for us, and now we can like, if you want, like you can like install the package. At some moment we will see how to install packages that are like available in the internet. And here is just like implementation of the function. But you can see so that the people here, they provided like a very pretty like long documentation for the function, and it's like very helpful, because now when I'm like, for example, using this function inside of the Visual Studio Code, if my editor is smart enough, it's gonna like fetch this documentation, show me while I'm like programming, and then for me it's much easier to understand what are the parameters, how can I like run this program, because usually they're like providing some examples even here. So yeah, and this is a kind of, I just try to convince you that the documentations are like an important part, and maybe even like some of you from time to time. I'm not saying that you need like to write it to every function that you specifying, but if you think that someone or even just you gonna like go back to this function after a while, then it's like usually good to have it. And what is very nice right now, that for example, if I have a function, let's like open back. So for example, if I have a function here, let's just try to utilize modern techniques that are like already available in the internet. So let's just remove it and say that we don't have any documentation here. Let's just copy our function, and now I want to go to chatgpt.com. So I think that all of you know it somehow. I don't want to log in. So yeah, provide documentation for the following function. So yeah, and this is you see, like, this is a nice documentation. Now you can just like copy and paste it to the docstring, and you have a nice documentation. And usually it understands what is like inside of the function. But you need always to double check, because sometimes it can like provide you some crazy thing which are not like in the function itself. Okay, this was like about the documentation. But now let's go back to the arguments, and I will create a new file. I will call it like function arguments.py. And as I showed you, so there was like example with the match function. I mean, like this again, the toy example that we want like to match pairs of the persons. And I said that in reality, there could be functions which are not like providing any, they don't need like any input. They just like providing the output. And to do that, we can like specify a function. Let's call it like pi constant. And here you can see, so I left it blank. I didn't specify any argument here. Then inside of the body of the function, I will right away return the value. Oh, sorry. So something like that. Let's add two more values. Yeah, something like that. So this is our function, and now we can call it in the same way. And you can see I left it blank because this function doesn't take any argument. So because of that, I left it blank. Now let's run it, and you can see, so we got the result. So this is an example of the function which not working with the input, and then like just provide us the output. Okay, but also there could be arbitrary number of arguments in our function. So let's create a function. I will call it like custom sum, and let's say that it takes two arguments. I put like a, b, and in reality, so the name here could be arbitrary. You can call it like, I don't know, x and y, and then you just referring inside of the body of the function to the arguments that gonna be provided by these names. So return custom sum of, return x plus y. And now I can like print custom sum and provide any values here. So in 10 in this case gonna be assigned to x, and 5 gonna be assigned to y inside of the body of the function. So we can check it that printf x inside of custom sum is x, and let's also repeat it for y, just like to double check that the 10, I mean the arguments assigned by positions to the names that we have here. So you can see, so that indeed when we specify the custom sum in this way, the x inside of custom sum is 10 and y inside of the custom sum is 5. You can put some other values now, and it's gonna work correctly. Okay, so this is the way how we can specify it. And then let's just try to kind of play a little bit with that. For example, if we specify just one argument, 10, and I don't provide the next one. So let's run it, and you can see so that we got an error. So type error custom sum is missing one required positional argument y. So basically, if you have like two arguments in your function, then function waits, and there is it's supposed to get two arguments. And in case if you're like providing less or more, so let's also try to provide more. I need to comment this part, otherwise I will not be able to reach the line number 13. And now you can see that we got like opposite. We provided 3 arguments, but function takes just 2. So this is an example that you can like face with some problems in the code. Okay, now let's let's implement one more function. I will call it like custom div for division, and there is A and B. And now I want just like to return the result. And again, so custom div, just like as an example, 1, 2, we got as a result 0.5. But now let's say that I want like to specify first value for B and the second as a value for A. To do that, inside of the, like during the function call, we can use the following syntax. So I need like to write that the B is equal to 1, and then after a comma, A is equal to 2. And now if I run it, you can see so that we got 2. That means that we can pass arguments by their names. We know that the name of arguments in our like implementation A and B, and then you can like say that I want like to specify B first, then A, and then it's gonna like match exactly properly the arguments with the values that you're given. So guys, so far so good. Do you have any questions? No? Okay, nice. So let's now switch to the default. Yeah, but guys, if you have, don't hesitate. You can like, like interrupt and then ask your questions. So it's like always a nice way of learning. Now I want like to talk about default arguments. And let's implement a function like a greeting again. Now we have like again name and then message. So, and we can specify the default argument for the we can specify default value for the argument. And in this case, it's like hello. Let's say that we want to use as a message hello. And then, so result is f string, and here is the message and name. And then return result. And now, for example, we can call our function, and the cool thing about it that now we can specify just one argument because we have a default value for another one, and that means that we don't need like to specify all arguments over and over. So for example, if the name, let's put some random name here, and let's execute the program. So you can see we specified just the name first, and hello by default was hello, we put it here. Also you can replace it. So let's say that you want to say hi instead of hello. Now you can like reassign the value for the message, and it's gonna be hi. But if you run it like again just with name, then it's by default again hello. Yeah, and there is one point about that usually you don't want to specify as a default value some mutable object. Usually it's better to have immutable objects. So let's, as an example, I will comment this part. Take a look on the following example. I will just copy and paste it. So here we have a function which is called like add item, right? And this is an item, and my list by default is empty. So the idea is that we won't like create a list during the function call and put the element there. And so by default, we think that it's like empty list, right? But now if we execute this program, so you can see so that we got as the final result both elements. But again, so the idea is that we created a variable result1 and we called add item, and like from my point of view, I would expect slightly different behavior. I would expect that in result1 there is gonna be just apple in the end, but not also banana. But you can see so that we got two elements there. Even that we are even that we have created another variable which is called result2, we also like called add item function with banana, but apparently result1 and result2 refer to the same object. And this is an example that you can face with some kind of troubles. And there is a way how to handle it, if I remember correctly. Yeah. But guys, did you get the point? Right?
So it would be the same one list.
Yeah.
Yes?
Yeah. So basically, the idea that we assigned like once the empty list, but then we reuse it. So if we added to this like empty list some value, then we will add again to the same list. We will not create another one during the new function call. Yeah, but there is a way. So let me try to. I believe I remember how it was. So for example, we can like rewrite the function a little bit. And let's put item, and instead of my list equal empty list, I will put none. So yeah, I didn't show you none before. So none, it's also like a object in Python which kind of corresponds to nothing. If you want like to have like say that this is a nothing, you can use none. And we will see so sometimes when we have like a function which doesn't return anything, it's gonna return by default none, because it's like as a saying that it doesn't return anything. We will see the example, but so here is just like as a spoiler, like spoiler alert. We have like none object in Python, and I will assign none here. But in reality, it could be maybe something else. But none is like I think the best point here. And now we can write my list or empty list, something like that. And then again, my list append item return my list. So let's execute it one more time, and you can see so now we got the expected. I mean, like, all of us have different expectations, right? But I expected to have just apple, not like banana in my list. And then so you can see that I got it. And basically, let's try to perform reverse engineering. What was happening? So here, when we provided apple and we didn't specify anything for my list, we have this construction which is like my list or empty list. And basically how it works, it checks my list. Is it true or not? And my list, the none object by default, it's a falsy values. And because of that, we will use the right side of OR operator instead of the left one. Yeah. In reality, you can write it in a more explicit way. You can write like my list if my list is not none, else empty list. But simply it's like very similar in this particular case. So you can see, so this is again the same. So we are like just checking if my list is not none, then we will use my list. But if my list is none, then we will assign to my list empty list. Yeah, I mean, like maybe it's a little bit frustrating, but you need like to kind of play with it a little bit. Let's create another like result 3, and now I want like to add item. Let's say that this is I don't know, strawberry, and I already had like some list. Let's say that my list is like blackberry, blueberry, and now I want to add like also strawberry, and I want to print my result. And you can see, so in the case if we specified a list, it's not none, and since it's not none, we will return my list back. Yeah, and add a new value to it. So this is an example how you can like handle the situation if you want to do something like that. But usually, yeah, we don't want to put mutable objects as the default values for our arguments, because in this case, I believe you will face with some problems later on in your code. I mean, because it's not like it's not expected, yeah, to have such behavior, but it is. Okay. Yeah. Now let's check how can we handle arbitrary number of arguments. I'll call it like arbitrary arguments. Maybe not very good naming, but let's do it in this way. So okay, our task now is to implement the function custom min. So we want like to provide values to custom min and get the result. I mean like, to find the minimum value of the values. So custom min, let's say that we take two arguments, a and b, and then we want like to return. So okay guys, what should I put here? Let's like just try to work together as a team. I want to find the minimum value.
So I think we should return like if A is bigger than B, return A, else return B.
Okay, yeah, I think that works. Let's check it. Custom min with -1 and 10. Oops. So it's -1. Let's try to trick our function. And it still works. Perfect, right? Yeah. Yeah, nice. Yeah, so, and now, for example, we want like to specify a function in the same way. And I will just show you the syntax, because it's not about... Yeah, so I will put like a keyword pass, because you can see I didn't specify anything in the function, and just like to avoid all errors, because if I just put it in this way, you can see so that I got like a Visual Studio Code highlights that there is some problems with indentation or all of this. I will put just pass and this like as a template. So this is the saying that I have a template and I will implement it at some moment. But now I just want to have it in this way. Now I want like to provide like arbitrary number of values. I don't know, something like that. And be able to run this function. And in this case, you can use the following thing. You can put a star symbol here, and then you need like to specify the name of the argument. I'll call it like args, right? Yeah, args. And basically how it works, so for A, in this case, in this particular case, we will assign 10. For B, we will assign -1. And args is gonna be a tuple. And inside of this tuple, we will have like a -5, 101, -1000. And let's just check that it's true. So we can print that A is A. Then like B is B, and then args. You can see so that inside of the body of the function, I don't use star symbol anymore. I just want to use args. This is just like as a syntax sugar to say that I want to put all values which are like going in the tail of our function. We want to peg them to the variable which is called args. Okay, now if I execute, let's put return none. Because for now our function doesn't return anything like reasonable. And you can see so that, as I said, for A we assigned 10, for B we assigned -1, and then args is a tuple, really. So, and inside of this tuple we have -5, 1, 0, 0, 1, minus 1000. And basically now, so we can handle the arbitrary number of arguments in our function. So I'll just comment this part, and we can, like in the same way as we had here, so we can write that the result is equal A if A is greater than B, else it's B. And then for element in args, we can check that the result is equal result if result is less than the element, else element. I believe something like that, but we will just check it. You know, so it's like very early here, so because of that my brain sometimes like kind of a little bit not working at the full capacity, you know. So, but we will check it. We will check it. Yeah, looks reasonable, right? -1000. You know, like they're like saying, right, that you how it was like when I was like a kid, they always was saying that you should know it even if they're like waking up you like during the night. Yeah, I'm like crazy, because I cannot like usually think if I'm like right away like after like I woke up. But this is a result. So guys, did you get it? So you now can specify the function and provide as many arguments as you want to it. Let's just try to check it. For example, if I have just 2 arguments here. And you can see it still works because in this case, let's uncomment this part. I will comment this part. And you can see so that A is 10, B is -1, and args is, sorry, I had the mistake here. Yeah, you see, there was a mistake. So, yeah, A is 10, B is -1, but since arguments, it's like a empty tuple, we will not like get any element here. And because of that, we also able now handle the situation where we have just like 2 elements and more. Yeah, so and
I'm sorry, I have a question. Tuple is like in Russian kartesh. Kartesh? Yeah. So
Yeah.
it's unchangeable object.
yeah, it's like a list, but you cannot change the values inside of it. Yeah.
Okay, thank you.
You're welcome. Yeah, and as I said, so you can put here any name, but args is the convenient one because usually because people usually use it. So you can put arguments instead of args. Then like you need like to replace everywhere args to arguments, and you can see so it works in the same way. I'll put it back to args because I like it more. Yeah. Okay, and there is also like a very nice trick that we can unpack arguments. So let's call it like unpacking.py. Let's create a custom sum. And let's say that we want like to have a custom sum which takes 3 arguments. And then we return A plus B plus C. And now I want to calculate the sum of my values. Let's say that I have like values and I want to calculate result. And for example, if I put values here, just like values as it is, we will get an error, unfortunately, or fortunately. Yeah, we got an error because we provided just 1 argument. And basically, so A now is a list of 3 elements. But in Python, there is a nice way that you can unpack values from an iterable object, and then they will be provided as an arguments to your function. To do that, you need like to put star before the iterable object. So it could be like a little bit confusing in the beginning, because we had like star as a way when we packed arguments inside of it, but now we are using the star to unpack values. But basically maybe as a mnemonic rule that can help you. When we want to pack, we put star in the definition of the function. So before we had like star in the definition, and if the star inside of the definition, then we are like packing everything to a tuple. But and if we use the star during the function call, then we are unpacking values. Okay, this is how it works. But now let's guys again, let's like work together. Let's work together. Now I want to handle the situation where I have like arbitrary number of elements inside of the list. For example, like that. And I want like to run it and get the correct value, not an error. So let's try to kind of, combine this like packing, unpacking, and resolve the task. So you can think, and then if you finish, just like let me know. Or if you have like ideas, also works.
What if we remove B and C arguments from the custom sum? There will be just A argument. We will give a function the list of our digits, and inside of the function we will make a sum for this digits inside of the list.
Okay, sounds reasonable. What should I put here instead of BC that it was here?
Like previously, args, no?
Args, like that, right?
Yeah, but I just thought that we can just have an only A argument without args. Is it possible?
I see. Just like one argument. Yeah. But,
yeah.
Yeah. So let's do it. Okay. Let's write it. And then inside of the function.
Yeah. Then inside of the function, I don't remember, but yeah, we can. How would I do? I would create like variable total, which is equal to 0.
Okay.
Then I would make a loop for I in values. For I in values.
Okay, let's call it values then, right?
Yeah. Total plus equal I.
Yep. And then return
I because there may be string objects in the list.
Yeah. Okay. Yeah, that's reasonable.
Yeah.
Yeah. Okay. Yeah. Return total. Let's check. Sorry. Yeah. Now we don't need to unpack it, right? Because it's just like values.
Yes, I think it's.
Yeah. So when it works, it works. Yeah. This is as a way to do that if you have like a arbitrary number of the list. But also we can like now slightly adjust it. For example, to be able to handle as many situations as possible. I mean, okay, at least like try to approximate the case when we have like a more, how to say it? I mean, like, so for now we are like just able to work with the list. So we have a list and then we can provide it and it's gonna work smoothly without any problems. But let's say that I want like to print custom sum of 2 values. And here it's not a list. And in this case, how we can do it? So let's create a custom sum again. Oops. I will comment this part. And here we go. So we can use, for example, values, kind of similar, but a little bit different. And then total is 0. And let's use it. So there is a rule, like if you have like an empty set, and if you're trying to sum, I believe there is a rule about it. So if you have like an empty set of elements, by definition, sum of these values is 0, and we will have the same kind of behavior. So total is 0, and then for element in values, total plus equal element. And we can also put int, for example, or float, it depends what we expect. And then return total. And now, just here we need like to unpack values, and then we have custom 1, 2. Let's check. And now it works. You can see so that it works like with the list, but for list we just need to unpack it. It works with the arbitrary number of just simple arguments. And then also we can just put probably, I believe we can do it, empty. And even with empty arguments, I mean, like if we don't have like any arguments, we also handle this situation, which is nice. Yeah, let me see. There is also like a point about there is a point about keyword arguments. Yeah, somehow I skipped it. So yeah, but you remember that at some moment I showed you that we can like specify names of the arguments and then provide them there, right? And in reality, so what can we do? We can create a new file. Let's call it. I'll call it keyword arguments, and I'll just put some things here to show you. So now we can also pack named arguments. So before we packed just like arguments to the tuple, but also we can pack named arguments. Let's just create a function. I'll call it like again greeting, and then let's just put it right away. So keyword arguments, and then let's just print it. Print keyword arguments, and then return none. And now I want just like to print greeting. And now, for example, if I provide named arguments, they will be stored in KW-args. For example, name is equal to Vladimir, and message is equal to hi. So you can see that in this case, if you provide the named arguments, I mean, like if you're like specifying during the function call the name of the argument and then also the value. We didn't specify here any like name, message, nothing. But we specified this syntax. You can see we put it like double star. And in this case, Python knows that we want like to store all named arguments in the KW-args. And indeed, so we have like a print KW-args that we have a name. It's like Vladimir, message is hi. So basically, we pack them as a dictionary. And now, after that, you can like utilize it in your program. So for example, if you need, sometimes you need it. You need like to have like named arguments because let's say that there is some, you know that you are like expecting to get some pairs of values and then like to, I don't know, just like to perform something. Let's say that we want like to have like a print, like a pretty print with the keywords inside of it. I will comment this part. And now I want like to create a for key value in keywords dot items. I want to print let's just like make some nice formatting. So the key is k and value is v, and then like return none. And now I want to just let's call it like pretty print. And now, for example, we can put like name, message, or you can like put something like person1. Let's call it John. Person2 is, I don't know, Julia, something like that. And let's run it. So then you can see so that you can handle so that there is a key which is a name and the value is Vladimir, there is a message. So basically you can like also handle the situation where you have like a multiple number of the keyword arguments. And in the same way, if you execute, for example, imagine that you have like a function call and then you put like something here and you had like a custom dictionary. You can then unpack the values in the same way. So yeah. I mean, in the same way as we saw that we were packing, unpacking just like lists. In this way, you can like also do it for the dictionaries. Yeah. Also, I would like to show you some example about return statement. So that, as I said, by default, if you don't have anything to return, by default Python return none. Let's create a function. Let's say like it's a greeting in the same way. And let's say that we have result. Result is just name, hello, name. And then, so let's say that I didn't specify return statement here. And now I want to get the let's call it like somehow res of greeting is equal to greeting with the name. Let's say that I provided my name. And now, for example, if I want to print the res of greeting, you can see so that this is a none. Even I didn't specify anything to return inside of the function. And this is a default behavior of the function. Now you can specify here result. And now there is a proper result. But by default, if you even like missed return statement, if you forgot to put it, by default Python will add it at the end of the function, because when it's like going through the body of the function, if interpreter sees that there is no return statement, by default it assumes that function returns none. Also, you can like put some values after the return statement. Let's say that I want like result now is like by instead of hello name, and I want to return it one more time. You can see so that in Visual Studio Code, because it's smart like editor, it's the shade slightly kind of more unsaturated, not so saturated as here. And then you can see that it's saying that the code is unreachable. That means that if the interpreter meets the return statement, then everything which just goes like after that in body of the function not gonna be reachable. So you can see we just got like hello Vladimir. We don't have any errors because it's still like inside of the body of the function, but this code simply not gonna be executed in any moment of its life, which is pretty sad, right? But you don't need like to, you should just like avoid such situation. You don't need like to provide some redundant code which is not gonna be executed. It's just like to kind of keep in mind that sometimes you can like write something, but it's not gonna be executed. And there is at least like two things. So maybe this part unreachable because of some bug, and you want like to be able to reach it in some particular cases, or it's like really redundant and you can like simply remove it without any problems. Okay, this is about return statement. In general, so I suggest you to take a look about the like slightly read more about arguments of the function, because there is a way like a generic thing. So for example, if you have like a function and then there is a generic way how Python handles like all arguments. I want just like as example show you. For example, here now if I call f, let's say that C, I want to change message, and then I want to put 1 and 2. You can see so that there is an error because positional argument cannot appear after keyword arguments, and basically there are like some kind of nuances, and I just like saying that you can check them in internet. I don't want like to waste a lot of time on that because usually you either gonna face with an error and then you will just like figure out what's happening, because usually it's really easy to check it in internet about the generic way how you should specify arguments in the function, and then how you should like also call them during the function call. Okay, this was about return statement, and now the crazy part is about like a recursion. This is a very crazy. So let's check, like, I don't know, before it was very fun. So if I open the Google, right, and now I want to put like recursion here, and you can see, so it's like even like playing a trick with me. So I like put it like correctly, right? I don't have like any typo here, recursion, and it's like asking me, did you mean recursion? Which is like crazy, right? And this is about the process. So the recursion is like a process with something where something like repeated, like usually can be repeated infinite number of times. Sometimes you can like even see it in real life. So if you put like two mirrors in front of each other, right? And if you stand there, you can see so that there is this like image is like repeated over and over again, which is like also recursion. And now we want like to we have like the same concept for functions, and basically it means that the function can call itself inside of the body of the function. Oh yeah, and I have here the example. So yeah, this is a factorial function, and in my mind there are like two important things. I don't know, have you already saw it like in the discrete math course, the recursion, or not? You already had it?
Yeah, yes. Like
We are familiar. If you mean if we are familiar with this, yeah? Is this
Yeah.
your question? Yeah, we have course of discrete. Okay, we have math course, and we during combinatorial things and etc. we were doing recursive functions with the combinatorial functions, like when we call the function again inside of the body of the function.
Yeah. This is that's it. Yeah. So and very crazy stuff. Yeah, and so I will just like briefly give you some kind of highlights of the recursion. Also, I will provide some some homework tasks about recursion, and I think that it's gonna be fun. I mean, like you will implement something, but then I will provide you also like a very cool article, very like a short article about, it's called like a permutation test. So in statistics there is a permutation test. In case if you want, like, or even I can like probably let's like do the factorial, and then I will like as an off topic show you like a little bit about the permutation, and then inside of the homework there is gonna be task about the recursion to implement the permutations, and you will I hope that you will kind of appreciate it, that you are able to perform some statistical tests after that. Yeah, so let's just copy and paste and let's go over it quickly. So this is a very simple example of the factorial function. And key point in recursion in my mind that we need like to specify some like a boundary case when we need to stop the recursion, because otherwise it's going to be infinite number of calls and we will face with an error, because we cannot like handle the infinite number of calls inside of the computer without any limitations, right? Because it's like infinite. And here, so we have like if n is equal to 1, then we want to return 1, because by default, by the definition of the factorial, factorial of 1 is equal to 1. And otherwise, if n is not equal to 1, and we assume in this particular case that n is like greater than 1, but you can provide string or something else and you will face with the errors. But let's think that we have like some value which is like greater than 1. And in this case, we will calculate n multiplied by factorial of n minus 1. So let's think that we provided 2 here. In this case, so n is 2. If n is equal to 1, no, it's not. Because of that, we will not return 1 right now. Here we have return n multiplied by factorial n minus 1. So we know that n is 2. We want to calculate 2 multiplied by factorial of n minus 1. And in this case, already n minus 1 is equal to 1. And because of that, this will be replaced, because we will go like inside of it, and we will check that for this function call n is equal to 1, and we will return 1. And we will yeah, I have here like as a visualization. This is a 4 factorial of 5. You can see so that we call like factorial of 5, and then inside of factorial of 5 we have like 5 multiplied by factorial of 4. And factorial of 4 also not 1, because of that factorial of 4 will be replaced by 4 multiplied by factorial of 3, and so on until like we reach to the 1. And then so yeah, you can see we replaced like a factorial of 1 with 1, then like 3 multiplied by 2 multiplied by 1, and so on until we will calculate what is the real value of factorial of 5. Yeah, that's it. And yeah, and now let's just I don't know, run it. Let's put some like a crazy huge number, 100. And we got like a such result, which is like interesting, right? So you know that factorial is like a very fast growing function. So if it's like 100, not 100, but 200. Yeah, already like a lot of numbers. So yeah, this is about recursion. I provided like a very simple example in homeworks. I'll try to kind of give you some hints to you will be able to resolve it. But it's, you know, sometimes it's like with this function for recursion, maybe it's gonna be a little bit strange. You know, like sometimes they like in the courses you have that they're like showing you very simple example, and then the tasks are like I don't know, build something like crazy that you're like they're showing you. Yeah, this is how like to nailed something, right? Like I don't know, with a hammer, so you can like put nail into the wood, and they're like, okay, now you get it. You need like to build I don't know, like some like I don't know, nuclear station or something like that. So it's not gonna be exactly that way, but maybe a little bit harder than factorial for sure. And now I want like to show you example about permutation test, and you will be able to find all possible permutations of the set that you have. And it's really nice, because then there is idea about permutation tests in statistics. I believe it's like Alpaca. There is a very nice visual explanation, just like of the statistical side of the permutation test. So you can see that, let's say that you have like some like Alpaca, and then you got like two groups, treatment and control, right? You have like treatment and control, and now you need like to calculate some, so usually you have like some statistics, some value, and you need like to calculate, are they different statistically different between the groups, right? And there are like a plenty of different statistical tests. You can like measure the average value and perform like t-test, Wilcoxon rank sum test, which you already done in your homework, right? I mean, like you just calculated the statistic, you didn't get the p-value, but the idea was that if you have these values, right, and these values, then you can like calculate ranks of them. And then the idea is if they are like not different, then the ranks will be like randomly uniformly distributed. So you can think about the ranks here. So you will have like a pink, blue, pink, blue, and so on. So, and that means that if you have this like sorted ranks not different, then probably there is no difference between groups. But this is another test, which is the permutation test. And here, so what is the point? We calculated some value. In this case, the value of the average, I don't know what they're like calculating. You can take a look later then. So you can like for your group calculate some statistic, some value. And in this case, we have like 1.6, for example. And then we can perform permutation. So you can see we permutated the samples. And in reality, so you can like perform it over and over again, like calculate all possible permutations, and it helps you to build the null distribution. So you got the null distribution for that, right? And then based on your observed difference, so you had like your real group versus like a treated group, so control versus treated, and then you need like to find values which you got after like all permutations which are like greater or equal than the observed one. And this is basically the ratio of these like highlighted circles to all of them is a p-value. Yeah, you can see. So this is n is equal to 16, and there is some p-value which is 16 divided by all of these things. So yeah, just like as a visual example. But this is, I'll send you the link. I think it's like very fun. Guys, that's it for today about the functions. We will cover some things later on during the course. There are like some things that I didn't show you yet, but we will do it. And if you have any questions about functions, feel free to ask them. And next time is Thursday, right? So it's like in 2 days. Okay, so if there are no questions, I will see you in 2 days, guys. Yeah.
Okay, thank you so much.
Can I ask a question about recursive function?
Yep.
We were using this type of function during solving task with combinatorial objects, but where we can use these recursive functions, because honestly, I don't know where to use them. That's why it seems really hard for me, because I don't know where to use it else.
Yeah, in real life, right? You mean like instead of... So, I mean, like combinatorial part of it, it's also reasonable, because, so for example, permutations, it's like it's a part of the combinatorial algebra, right? So, and in this case, I'm showing you that it's indeed can be used in some cases. You can like really, if you have like a small samples, for example, if you have like, I believe 5 versus 5, then you can like find all possible permutations by using the recursive function. But also where they're like very handy, usually if you have like a tree structure, so if you have like something which can be represented as a tree, this is like just a matter of the process that you are studying. But some processes can be visualized as a tree, like as a network. For example, you can think about it that there are like networks which like specify protein-protein interactions, right? You can think that there is a protein, and if it interacts with another protein, you can like think that you have like two vertices, and there is an edge between them, and you have a network of it. You will have like a let's just like two kind of tree structure. Tree is like some particular one. So yeah, you have something like that, right? And for me, usually it's boring because it's like okay, there is a 1, 2, 3, but what does it mean? But in reality, so you can think about it if you have like some process which, I don't know, for example, you can think that was a cell, right? And then it divided into 2 cells. And then this one divided into 2, and this one into 2. Somehow this one didn't divide in 2, right? Maybe there is like something interesting with them happening. And in this case, if you have such structure, sometimes you want like to find, for example, such cases that there are like some nodes which have just one child. This is called like a child. And usually for such cases, it's much easier to implement the recursion, because with loops, it's harder to handle it with the loops, because it's like more natural to think about them as a recursion. So you have like a node, and there could be childs or they could be absent, right? And then you're like going, so okay, I want like to check all. I mean, like, for example, I want like to check the first child. Okay, I go here. Okay, this has 2 childs too. I'm like, okay, let's go to this one. You checking this one, then to this one. So you can basically go always to the left. Okay, you went here, and this doesn't have anything. So you can think about it. Okay, maybe it's didn't divide yet, or will not divide in any point of life. This division is like a first thing which came to my mind. So it could be like something more reasonable, right? And yeah, so basically you can then highlight such cases. Also, there is like specific algorithms which are based on that, which are called like when you need like to search something, then usually you're like using recursion and you're like going through this like nodes. There is like in-depth recursion, or like to the I don't remember exactly how they call it in English, but yeah. This one, okay, also another one. So from linear algebra, guys, something that you really like, right? Linear algebra. So there is something which is called like determinant of a matrix. And if you want to calculate determinant of the matrix programmatically, there are some implementations which based on a recursion. Let me find, maybe it's like but basically the idea is that there is a specific property of the determinant which allows you to calculate, and you can think about it. Oh, okay, he's giving me like a determinant, how it like corresponds to real life, but in reality it is, guys, it is, which is like very nice. So for example, simple task, right? You want to measure the volume of your room, and then you can like use a determinant. You can measure the length. I mean, like you need like to find three vectors. Okay, let's think that your room is not like a doesn't have like a rectangular sides, right? Which is strange. You're like living in some strange room, but let's just imagine that you're like living in something. Where do they have like a? Yeah, so you are living in such room, right? Where your edges are not rectangular. It's like a parallelepiped. But then you need like to measure the volume of it, and you're like, okay, I can use a determinant for that. And you're like, yeah, but who cares about the volume of such stuff, right? But in reality, so each vector here, you can think about it as a gene, right? So you have a 3-dimensional space, and you have each axis, it's a gene, and then you have a sample. So, and you see that this sample alongside of this gene has a high value, which means like somehow it's like, I don't know, affected by this gene. Another one doesn't, so it's like by this axis, the value of this one is like low. And then you can like measure, for example, the volume of it. And if the volume is very small, right, you can think about it that, I mean, there are different cases, but you can think about it that maybe all these vectors are similar because the volume is small. That means that the vectors are like close to each other. That means that they form a very tiny this like parallelepiped, and the volume is very small. Yeah. And usually it's like a matter of how you like interpret things. If you can find like some visualizations, then it works. Yeah, because this like vectors, you always can map probably most of the things in real life. Usually you can map them to the vector. For example, the stock price, you can think about it as a vector too, or like the all shares in the stock price. You can think it's a huge vector, and then you have like the value per specific moment, per specific minute, another like minute, and you have like some changes. And then you have a multi-dimensional space where each vector corresponds to the value of all the shares in the... Yeah, basically, I'm like a little bit kind of went like crazy. But yeah, so I mean like to measure the determinant, in this case it's like a simple, you have like 3-dimensional space, but sometimes you have a large square matrix and you need like to find determinant, which is also gonna be as a volume of these vectors in multi-dimensional space, and then you can use the recursion there. Yeah, that's it.
Thank you very much.
Yeah, welcome.
for-
Yeah, thank you for the class.
Yeah. Okay, guys. See you in 2 days.
See you again.
Yeah. Bye.
Bye-bye.
Thank you. Goodbye.